So if you watch the other videos, you saw hypothesis testing with a proportion, hypothesis testing with a mean, claims about a mean and a proportion. Now they were all single samples. Okay? What we're going to do now is start looking at two samples. When we compare two samples from two different populations and then see if there's a difference between the two, significant difference between the two. See if one's greater, one's less than. A lot of the steps are going to be exactly the same. A lot of the procedures are going to be exactly the same. So we're going to move a little faster. This first section is just to introduce what the two samples look like. The null and alternative are very similar, just a very small change to it, and the pieces that you need. Okay? So what we're going to look at in comparing two samples, we have dependent, independent samples. Okay, so your job's going to be to read the problem and decide, okay, is there a pair here that we're looking at? If there's a pair, I consider them dependent samples because what happens to the pair first, what the reading is, the recording is, that's what you're going to compare to after you have some kind of treatment or just some time period. And a lot of times it's before and after. The independent, this is two completely separate groups, two completely separate populations and two separate samples that you're going to be looking at. Okay, there's no real connection. You couldn't pair each person up or each observational unit up. Okay? So for the dependent samples, matched pair test is usually what you're going to hear this as. This is a matched pair test, and like I said before, it's a lot of before and after, pre-test versus post-test. Okay? You have your observational unit, you get a reading about that observational unit, and after you're done some kind of treatment, some kind of exercise, you take another reading from that same observational unit. That's why it's a matched pair test. You're getting one reading and then another from the same observational unit, and we're going to see the difference between those two. If it's independent, these are two completely different sets of people. So here we have the weight of adult males in PA versus weight of adult males in New York. Those are two groups of people that are not related in any way. You couldn't take one person from Pennsylvania, match them with a person in New York, and have them just be a matched pair there. They're two different from each other. So completely different groups of people. Okay, so today we're going to look at the pieces for the matched pair test. And the first thing we're going to look at is our null and alternative. There's going to be two ways you can write out your null and alternative. Okay? One is using the mu symbol with a little d next to it. That shows that you're looking at the difference between the two averages. So statements will always deal with the mean of the difference of the two samples. And this is going to be looking at the parameter, the mu, of the population that we're looking at before, population after the treatment or exercise that you go through. So one way to write it out, the null still always has the equal sign to it, is mu d equals 0. And if you think about when I show you the other way to write it, we're going to see the algebra to work through it. The other one is still not equal to, less than, or greater than. So the other way you could write this out, your null and alternative, since we have two samples, we're comparing an average of before, the average after. We could look at the mu, I'm going to label it as mu1 equals mu2. The average before compared to the average after. You would label them as what they would be before, after, pre-test, post-test, something like that. But that's what we'd be comparing, the average of those two populations. And the reason you would have mu equals 0, and if you're looking at the differences, well, if they are equal to each other, let's think of the algebra for this. Okay? If we would subtract, if these are equal to each other, subtract a mu here, subtract a mu here, well, the difference, mu difference equals, if they are equal, is going to be 0. Okay? The difference between the two. Now, if they're not equal, that means the difference would not be 0. Okay, and if you have greater than or less than, again, you're going to have a positive answer, negative answer. Thinking of the subtraction and what happens. If mu1, the average 1, is greater, you'd have a positive difference. If the mu2 is greater, you'd have a negative difference. Okay, so that's why you could write it. I like writing it out this way, and that's how most of my examples are going to go because I think it's easier than to come up with your conclusions, to think through what's happening if you can label both averages so you kind of get a better idea of what the situation is. So now we're just going to look at some examples of just writing the null and alternative. Study was conducted to find the effects of a new UV protection cream. A sample of 20 individuals was taken and their skin condition was analyzed and rated 1 to 100. 1 being bad skin, 100 being good skin. The new cream was used for 1 week, and each day the individuals must spend exactly 3 hours in the sun. Their skin was tested again and rated. Does the new protective cream bring back the quality of people's skin? So this is what we're asking. Does the quality increase? Does it bring back the quality of someone's skin? Okay, so I'm going to start off with my null and alternative. Null's the same. And I'm going to do it as mu before equals mu after. Just a quick label so I know what average I'm looking at. And now we're going to have mu after, or sorry, this is not mu after, this is the alternative. We still have before, we still have after, and now we're on thing, okay. Their skin was tested again and rated. Does the new protective cream bring back the quality of skin? So I want to know, is after we do this experiment, after we put the cream on, we sit in the sun, does that bring back the quality? So is this the greater quality rating? And 100 is good, so that would be the higher rating. So I have greater than. Okay, so it's not a value this time, it's another average that we're comparing. Okay, so there's one example of writing out our null and alternative. Another example, kind of the same situation. A study was done to test the damage that sun does to a person's skin. 20 individuals had their skin analyzed and rated, 1 being bad, 100 being good. Same situation. The 20 individuals were put in the sun for 3 hours each day with no sunscreen from 12 noon to 3 p.m. Their skin was rated again after a week. Does the sun lower the skin rating? So start off again. Null. I'm just going to do before equals after. Abbreviate a little bit, speed things up. Before and after, and now I'm just going to sit here and think, okay, does the sun lower your skin rating? So right there, it's saying it's going down, so we know after is going to be less than the before. So there we go. Okay, so there's your null and alternative. Same as before. No matter if it was a proportion, no matter if it was an average, you always had to come with your null and alternative first. Now you have your null and alternative, and now going through the same steps, okay, we're going to do the critical value method like we did before, okay, just like we did the mean, so we're going to use that same chart. You still have degrees of freedom. N is the number of pairs that we have, so it's the number of matched pairs that we have, minus 1 is your degrees of freedom. You'd go to that chart, and you remember, you still have to worry about left tail, right tail. Okay, is it two-tailed? That you're looking at the alternative. All this is the same as when we did it in the last section. So we're going to look at this chart. We'd have to decide two-tail, one-tail. We'd have to decide the column depending on our confidence level. We have 0.05, 0.01, 0.001, 95, 99, 99.9% confident. And our degrees of freedom is the DF column there, and that is N minus 1. So all is that the same. Okay, you have your null and alternative, you drew your curve, you decide is it left tail, right tail, or two tail, depending on your alternative statement. And then you go to this chart to figure out what our critical value is going to be. That critical value is going to tell us where the reject, where the fail to reject area is. So once we did this, we have all that information, we have our chart written down, now we have to find our test statistic. So finding our test score, what we're going to do, we need to look at the difference of the two samples. So what you would have to do is subtract each pair, and you want to know the difference. And that is going to be the list we use to get our summary statistics. Now, a quick way to do that on your calculator. If you have your two lists plugged into your calculator, you can have your calculator do the subtraction and store it into a third list. Okay, and I'll go over that a little more detail when we do an example, but you have your two lists of data, the before and after, or whatever you're looking at, and if you plug it in as L1 minus L2, if you have it in list 1 and list 2, and then store it into L3, that's going to do the subtraction for you, and it'll speed up finding the difference of the two samples, because once you find the difference of the two samples, you need the mean and the standard deviation. Well, if your L3 already has the list in there, you can go ahead and do one variable stat, and that'll get you the mean and standard deviation, and you're using the L3 for that, And the formula for the test stat or the test score is the sample difference average divided by standard deviation difference divided by the square root of n. And just like before, I'm going to put parentheses around that part there. Okay, that's going to be our standard error. That's what we're dividing by, and that will give us our test score. You use that to judge if you're going to reject or fail to reject. That's what you bring back to your curve to decide where it falls to see if you're on reject or fail to reject. Okay, so those are the pieces you need. If you watch the next video, we're on to an example, walking through everything, drawing out the curve so you can see what points we're going to get.